Anytime you have log base anything, and there's a 1 inside your log, okay, think about what this has to equal. A to some power equals 1. Well, what power would you have to raise a to in order to get a value of 1? Always going to be 0. Again, this is true because a to the 0 power is equal to 1 if you look at its exponential form. Okay, so you want to be aware of that. If you recognize it, it's a little bit of a shortcut. Okay, what if you have log a of a? What if you have the base of your log exactly the same as whatever is inside your log? What power would we have to raise a to equal a? 1. So again, you can justify this using the properties, the conversion into an exponential form. A to the first is equal to a. Okay, so that should be a shortcut. You shouldn't have to go through and work through those types of problems if you see this form. Okay? Go ahead and shut it down. Right. What about if you took this expression? So if you have the log base a of a to some power x, if you think about the exponential form, a to what power is equal to a to the x? What would that power have to be? X, right? So once again, one of the things that you're going to see here in just a minute that we'll talk about is anytime you have a power inside of a log, the power can be moved out in front of that log. And so we could have taken this and written it x times log a of a. And since log a of a has a value of 1, we see that that expression is going to equal just x. You can justify it in that form as well. Right? The next property to be aware of, if you take the product of two factors inside of a log, you can expand this out in the following way. You can take the log of the first factor and you can add that to the log of the second factor. Okay. Yeah. Uh-oh. All right, so when you're looking at this particular form, if you have the log 5 of 25x squared, okay, the way that you can expand this out, and again, the terminology used to describe this is expand or an expansion. Okay. In looking at that, what you could do here is you could take the different factors that are embedded inside the log and separate them. So you could rewrite this as log base 5 of 25 plus log base 5 of x squared. So you can separate those out. And now we can continue with this, right? Because how can we describe 25? 25 is 5 squared. So if we thought of that as log base 5 of 5 squared plus log base 5 of x squared, okay, what can we do with these powers? We just saw up here, we can move powers out front. So we can continue to simplify this in the form 2 times log 5 of 5 plus 2 times log 5 of x. And what do we know? What can we replace log 5 of 5 with? Value of 1. So we can simplify this even further. 2 times 1 plus 2 times log 5 of x, so that you get your final simplified form of 2 plus 2 log 5 of x. Okay, now eventually this is what the rest of this section is dealing with. It's called expanding and condensing logs. This is the expanding part of it. ACT will also very likely contain some problems dealing with this. Okay, so I did want you to get some exposure to it. Okay, the same holds true with division. If you take a quotient inside of a log, you can expand this out as well, but this time the expansion isn't a sum of logs, it's going to be the difference. So any factor that exists in the denominator of a fraction is going to have a negative sign in front of it. Any factor that exists in the numerator of a fraction inside of that log is going to have a positive coefficient.